Okay, let's start with the first talk. And your...
Can you
I'll
hear
keep
me?
a timer.
But, okay. When you say?
Yeah.
Okay, perfect. Well, this is going to be a bit crazy, but as I told you, this is a talk about my personal project, which is an Astrodynamics library written in pure Python in 5 minutes. So, what is Astrodynamics to begin with? Well, it's a branch of mechanics, which is itself a branch of physics, which studies practical problems concerning the motion of rockets and spacecraft through space. To be a bit more specific, if you are aware of the Rosetta mission, it took 10 years to get to the asteroid, to the comet, and this is the orbit that the mission followed. Okay, so it had to go make an Earth flyby, then Venus, then Earth, then an asteroid, then Earth again, then another asteroid, and then the comet. So it's quite complex. It's like cosmic billiards. Well, it's like the experts say. So what is Polyastro? It's a library that I've been making to study these kind of problems. So let's go to Mars. These are some imports that we have to make. This last line over there is to download some file from NASA, which will tell us which are the positions and velocity of the planets. First of all, we have to define the orbit. To define the orbit, we need the attractor, which is the Earth, the Sun, or whatever. We need the position, and we need the velocity. So we give those. We use the AstroPy units module to give that in kilometers and kilometers per second. So we will have a function to plot the orbit. So second, we have to locate the planets in the solar system, and that was what the NASA files were for. I give the time, also an AstroPy time, and I call this function to retrieve the position and velocity of the Earth, in this case with respect to the center of the solar system. So I already have the position and the velocity. The third one would be to compute the trajectory. This is called in the literature as the Lambert's problem, which is given the 2 points in space, what is the trajectory that goes from one to the other, given also the time of flight. So I decide there a couple of times. I retrieve the position of the Earth and Mars, and using this Lambert function, I compute the two velocities, which are the velocities that I had to develop to go to these positions. And fourth, let's go to Mars. This is a lot of boilerplate code to compute all the orbits and also some plotting code that is not interesting at all. But the thing is that this is the plotting of the Mars Scientific Laboratory, which is the orbit that the rover Curiosity followed to go from the Earth to Mars in 2013 or something like that. But I can even go a step further and make it interactive. So if I go here, as I told you, this problem depends on the time of flight and the initial position. So if I move the initial position, you will see that the Earth is going to move forward in this orbit, okay? And if I change the time of flight, you can see that also the trajectory gets shorter or longer, depending on the trajectory. Oh, max number of iterations. I have to fix that. Okay, last of all, I don't know if I have still 1 minute, but this Polyastro thing, it's called this way because I created it while I was studying at the Politecnico di Milano University. So I wanted to dedicate this talk to this wonderful university and this wonderful country. Thank you very much.
You can use my mic. Next up is Scape.
Hi, I'm Dennis, and this is Niklas. We'll talk about Scape. Let's build an exploit. First, something about Scape. Scape is a networking library that lets you manipulate and send and receive low-level TCP/IP packages.
First, a simple and traditional example. For example, we want to implement traceroute. This is implemented by sending a TCP packet to an open port. And when we decrease the TTL to get error messages from the routers in between. And here's the start of a short implementation. As you can see, it's very brief and becomes very powerful, which implements a simple attempts to open a TCP connection to ping subnet SE. And it prints the responses of the received packages, as we will see here. And we get a list of router, their hop distance, and the true indicates that it's a TCP response that we have reached our destination. And so a trace route.
So from the IPv6 implementation, if you receive a current hop limit value of non-zero, you should set the current hop limit variable to the received value. In an IPv6 router advertisement header, you see the current hop limit and router lifetime fields that are quite interesting. Which means that if we take Scape and create an IPv6 packet, set the destination to the local network, set the current hop limit to 1, and send it out, bang. You are now with a global level of hop limit set to 1, and you can no longer route IPv6 packets if you have this vulnerability in your kernel. And that's global for all networks. So that's pretty much what happens when all vendors screw up IPv6. Mac, BSD, Linux, Android, Windows, all vulnerable. Thank you.
Okay, next up is Johannes with Why I Love Python.
And so the interpreter, it invites you in. It allows you to make simple multiplications, and it really gives you a way to learn what Python is and how to use it. I don't know about you guys, but I use the interpreter basically every day when I program in Python to try things out. Secondly, dynamic typing. You don't need to figure out a lot of different fixed typing. Basically, you just write your code like you're thinking in your head. And if you combine these two together, they become really powerful. If you execute with Python -i, you run your script, and then you get the interpreter, so you can continue to basically investigate the state that your Python script created. The types, the native types, they are great. You have a couple of them, and they are all really thorough. They fill a big purpose, and it's not just about them being here, being visible. It's also about them being native objects. This is important because you don't have to figure out if it's Stirlen or strcpy or whatnot. You really just you look at your object and you figure out what to do with it. So let's say you have a string, you put it to some value, and of course if you want to decode that in UTF-8, that's a method on the string. And there are a lot of other stuff. Even the integers are objects, so you can find a bit length there on a 1, 2, 3 integer. And next up is dir, inspired by DOS, I'm sure. Basically, this is the next step when you use the interpreter. You use this to investigate your object. So if you look at the string here, you can see all the methods you can use on that string. So it really removes the need for going through the documentation every time. You start with interpreter, you start with your code, you run Python -i, and you go. Functions are first-class citizens. So let's say you want to have a optional logging here in your software. You can just, well, I think you see what the code here does. Basically, if you have this option set, you open a log file and you replace this method with a write from that file object. This is just a very simple case of what you can do when you have functions as first-class citizens. Another thing I really like about Python is that OOP is not mandatory. So what you see here is a simple program. It opens a file, a players.txt, it goes through all the lines, and it removes the comments, and you have them there in a list. There's no need to set up a big skeleton for this. This actually makes, this is a real program. It solves a small purpose, but still a real purpose. So, and then you have the awesome standard libraries. And if you're not satisfied with URL-lib, of course, you'd use request. But and lastly, it works everywhere. So basically, you create your code, you put it out, and run it. So these are most of the reasons why I love Python. Thanks.
Next up is Plotly.
Okay, thank you very much. My name's Carol Griffiths. I'm based in the UK, and I'm covering Europe for Plotly. There's about 16 people in the company, based in Montreal, in Canada. The idea came around because the guys were mostly data analysts, working at places like Facebook and also Stanford University as physicists. And what was happening, they were passing around graphs, and as they were passing around graphs, well, the data was in that file over there, the graph was in that file over there, and somebody would get the graph and goes, where's the data? And I said, well, hold on, why don't we put it all together? So that's what they've done. Here is a feed on the Plotly feed. If you can look at this now, you can see that we've got people now coming and joining us. You can get free licenses. You can have up to 10 private files of your own. We don't charge for that. We have a lot of students, school kids, university students, postgrads using it, and a lot of people like to share. But you don't have to. You can have up to 10 private files if you want to. Well, what I'm going to do now, I'm very quickly going to do a quick demo. So it's quite brave of me, because I'm relying on the Wi-Fi a bit, but just to give you an idea what it's all about. What I'm using here, I am using Spider, which is Anaconda. I'm using 2.7. And you can see here, I've got a Python script. And what I'm going to do, I'm going to very quickly, I'm going to copy it. And then I'm going to paste it into the console. And there we go, it's starting to run. But what we can see here, we're importing matplotlib, which we're using with Python. We're also importing NumPy library, and we're asking import plotly as py. And we can see we've got the code here for the scatter plot we're going to plot. And then we're asking it to go to a URL, which we're hoping it's going to do, because I told you I'm being very, very brave here, because you know what it's like when you do demos. Now, hopefully, this is going to open up the actual Plotly for us, but if that fails, we will carry on with something else until it does. Okay, until it does, we'll get on with something else. Okay, time's limited. Okay, Plotly APIs, libraries, we've got various for scientists out there, or engineers. We've got scientific graphing, for instance. We've got Python, MATLAB, R, and Node.js, Julia, and also Excel. So these are all the methods that you can import your data. If I go here, I can show you the different types of chart types that we've got. We've got line and scatter plots. We've got error bars, heat maps. We go right down to even 3D plotting. So we've got an awful lot there for you. I've also opened up one little window here, which will show you one that I've done earlier on a different one, just to let you know a little bit about it. This has been imported from Python. You can see it's 2 trace lines. And what we've done, we've imported it using Python. And the beauty is that the data and the code stays with it. We translate it into JSON, which means that we can then access the original Python. You can see here, we've got the Python, and we can also then if we need to, translate it to MATLAB so you can talk to any colleagues that are using MATLAB, for instance. If we go here, we've got the higher level data. So we can communicate now with the management within a company because they seem to be able to understand that better than the coding. And we've also got the facility here to attach any original data files with it, so the original data files are not lost. So we've got the plot, we've got the data, we've got the code, and the original information as well. I'm also going to now quickly show you something else that will save you an awful lot of time. Am I running out of time? 50 seconds? Okay. Right. For example, if you are, for any reason, programming in Python to change things like layout or the legend, for example, that can be quite a bit of coding. But Plotly, it's just a matter of clicking on this. We can change our trace colors, for instance. We can go in, change traces. If it's working. Relying on the Wi-Fi again here. So we can change traces, we can change the colors, we can change the axes, titles, X, Y axis, etc. And the beauty is we can then export it. And the quality of exporting is absolutely wonderful for publication, so you don't have to get any graphic artists involved. Okay, and thank you.
Next up is Andreas with Click. Yeah, cool.
Okay, so yeah, I'm Andreas. Today I'm gonna show you how you can create beautiful command line interfaces with Click. So most of the time, you type up a script, you run it from Python, and you're kind of happy with that. Everything works. You're happy. But then you figure out you actually need to pass some option to your script. So you start out by looking at argparse or optparse that's bundled with Python, and you get really frustrated, and you just leave it, and then you just look into like sysargv and try to parse everything yourself, and you're really unhappy with that, but you somehow work it out. And then you may need to read a file. So you need to pass in a file name and read a file. So once again, you look into sysargv, you get the file name, you open the file, you read something from it. If you're doing it properly, you close the file and do all the things good. But that's a lot of work. And then, but you make it work. And then you want to read from standard input, and then you have to add a special case for that too. And you have to do all these sorts of things just to make it a good command line tool, or make it actually usable. And then you want to write a help text for it, and then you added all these hacks, and you have no idea what your program does anymore. So it's even hard to write the help text. So I'm going to show you how you can use Click instead, and how Click can help you with these problems. So can anyone see that? Yeah, okay. So I have a very simple script here, a hello world script. We can just run it and print hello world. So I'm going to change this to use Click so that we actually get a usable help text and that we can easily add options to it. So first I need to install Click. Can just install it with pip. And to convert this, I need to decorate the main method with the command decorator. So I import Click and use the command decorator. And if we run this again, it's still the same thing, it just works. But the thing is, now we also actually got the help text that actually looks nice and what you expect. So still not very, very fancy, but you actually get a help text. So imagine we want to add an argument so that we can pass, we want to print hello world multiple times. So we just want to pass a number with how many times we want to repeat it. So we define an argument by adding another decorator. So we say click argument, count, and it's an integer, so type int. And then we get this count passed into our main method, so we can just use it directly. So we can create a loop here. Well, something like that. Let's see if that works. Okay, so that works. So that's a really simple way to add an argument. And we get the help text for free. So if you do help again, we'll see that it actually added the count argument directly to the help text. Okay, so let's do something more complicated. Let's read something from a file and print it. So we want to have an argument for a file. So click supports multiple types of arguments. So we add another argument for the input file. And instead of int, we say click.file. And we want to open this file, the input file, in reading mode. So it's the same flags that you use when you open a file. And again, we get the input file passed in. So if we want to have the name from the file, we still need to read from the file. And just strip the white space from it. Something like that. Just add name there. So now we can run this thing again. And I have a file that with a name file. So we just get the name passed in. And last, I just want to show you that this also works with standard in. So it behaves like a good Unix tool. So you can just do echo, pass something in from standard input, and it just works too. So that's Click. It has a lot of more features and types and sub-commands that you can use, but it's really simple to get started for small things, and I think that's the most important part, so it's easy to get started. Thank you.
We have time for a 6th lightning talk as well, so it's going to be Iyad Sibay.
Yeah, hello everyone. So I'll talk very briefly about this tool. But first, so recently I was working on a side project for myself to automate many of the stuff that I do before doing some data analysis and machine learning. I mean, for example, one of the things could be feature extraction. Let's say you have a column like timestamp. So you can get out of that start of the month, hour of the day, weekend, weekday, many stuff that you can say. First quarter, third quarter of the year, and so on. And another things could be, for example, that you can automate is the model selection based on your data. So there are type of models that work with type of data and stuff, and you can make that decision quickly. What I wanted to do is, so I can iterate and try to use many type of models at the same time. And one of the things that's also, I feel, is fundamental or essential is the plotting or visualization. So I tried to make a very simple tool. I call it brute force plotter, which like you don't really need to think a lot. You just feed it some data, and it will try to generate all type of plots that you can plot from this data. So let's just go over the demo right away. Can you see this? So yeah, so let's say it's the most common example that people use, of course, is the Titanic. Is the, let's say, the Titanic data. So this is how it looks. These are the columns. And to use that tool, of course, you need to feed it the column types, the data type of each column. So this is an example file too. So C means category, N means a numeric category, whether it's ordinal or non-ordinal, and I means ignore. So, and then we can use it just like that. Let's see. So, and it's printing all the type of combination of type of plots that it's now plotting. And then we can see the examples afterwards. Yes, so let's go to the output folder. So we have here 3 folders. Let's go to the distributions one. So for the age, I have the histogram with the kernel density. Up and down there is a violin plot, which is similar to the box plot. And for example, for this other category variable, it's having kind of a bar plot and so on for every single column there. And not just like that. So we have also the interactions. So the interactions between every 2 variables. Okay. Again, so here is the scatter plot between the fare or the price and the age, the number of the number of siblings here, I believe, and here since impact was a category variable, it plotted this type of plot, which I mean, there is duplicate in the data between every subplot here, but I mean, so you could choose the one that you prefer to look at, violin plot, box plot, whatever, and so on. So I'm having, yeah, and also if the 2 variables or the 2 columns are category variables, I can have this type of plot, which is kind of also bar plot, splitted by count, or I can have a heat map. So this code is available open source in GitHub. And yeah, thank you.
Thank you very much. So that is the end of day 1, except for the fact that your drink tickets are now redeemable in the bar at the far end. So I hope to see as many of you as possible there for some mingling and talk to a few of you. And remember to talk to the speakers, because a lot of them have traveled here and they have no friends here. And yeah. So talk to them and buy them an extra beer or so, especially the ones that have already talked today, because they have no job tomorrow, so buy them an extra beer or 2. Thank you.